Hello friend, welcome to Dr. Subhash Technical Campus, Junagadh. Now today's tutorial topic is PN junction diode. It's simply called semiconductor diode. Now let's take a look. Now PN junction diode is nothing but one P-type semiconductor material and one N-type semiconductor material will attach together and make a one junction. So it is called PN junction diode. Now P-type semiconductor is nothing but it contains majority charge carrier is hole and minority charge carrier is electron. Here N-type semiconductor, the majority is electron and minority is hole. This is the symbol of PN junction diode, and inside the PN junction diode in P-type semiconductor this is acceptor atom, in N-type semiconductor there is a donor atom. Means here the majority is electron and here the majority is hole. So this one is about the PN junction formation. Now why the PN junction is nothing but when initially joined electron, means here the majority electron will transfer to the P-type material, and here the different hole is available. Whenever electron will fit into the hole, means electron hole recombination is occurs. In this region there is no any free electron or hole, so it is electrically neutral and electron hole disappear because the ion is completed. So this leave the region in the free charge carrier and depletion layer. So it is called depletion layer region, and there is no charge, so its work as a insulator. So we can say that this region act as a insulator and it not allowed to pass any current. Now barrier potential. According to the width of depletion region, we know that here some depletion region is there. Whenever the electron will move from N-type to P-type, or hole will move from P-type to N-type, at that time some potential, the breakover potential is required, and this is nothing but barrier potential. This barrier potential is depend upon the made up of semiconductor diode. Suppose if our diode is made up of silicon, then 0.7 voltage is required. If our diode is from germanium, then 0.3 volt is required. We can say that simply 0.7, minimum 0.7 volt required for silicon diode to turn on, means it allow to pass current from it. So whenever diode is here, we can use diode in two condition. The PN junction is also called as a diode. Now what is diode? The term diode is from Greek roots. D means two and ode means path, means there is a two path available or two terminal is available, anode and cathode, so it is called diode. It's used in various electronic application. We will use this diode to form transistor and FET, or some diode are also used in the logic circuit. In digital circuit is also used diode. This is the practical symbol of diode. This is the cathode, this is the anode, and this is the symbol of diode, this cathode, and this is the anode. Here the white strip indicate the cathode and this is the anode. The two terminal device is diode. Now diode works in two region. The first region is forward bias region and second region is reverse bias region. In forward bias it allowed to pass current from it, and in reverse bias it does not allow to pass. Now what is the condition of forward bias? Whenever anode, this is the anode, this is the cathode. Anode is positive and cathode is negative. When we connect the one battery, this is positive, this is negative, and this condition is known as forward bias condition. And in forward bias condition, this depletion region is very narrower and it allowed to pass current. The direction of current is like this, and the flow of electron is in reverse direction. So we can say that this diode is in forward bias. Means you have to remember anode is positive, cathode is negative. So diode is in forward bias. Now in reverse bias, the condition is reverse. Here the anode is connected to negative and cathode is connected to positive. So here the width of depletion region is increased and it does not allow to pass any current. So diode is in reverse mode or in open circuit mode. So the resistance of reverse bias is very high compared to the forward bias. So this is the two condition you have to remember. Now, if we draw the VA characteristic, then I versus V or V versus I characteristic, then the two region, forward region and reverse region. In forward region, after 0.7, if our diode is silicon or germanium 0.3, after 0.7 volt, the diode become on, means suddenly increase the current after 0.7 volt. Now in reverse bias, there is no any current up to reverse breakdown. Now this is the avalanche breakdown, means whenever we increase the reverse voltage very high, at that time permanently break the junction, and it is called reverse breakdown. So this one is about the characteristic of the diode. You have to remember this characteristic. Now this slide you have to remember about the diode. The first you have to remember, diode cannot conduct in reverse bias, and diode always conduct in forward bias. For silicon it is 0.7 voltage, and germanium it is 0.3 voltage. This is called breakdown voltage, knee voltage or barrier potential or breakover voltage. The 0.7 for silicon and 0.3 for germanium. If you have any query or any question, then please write to in this email ID chetanb@drsubhashtech.edu.in. Okay, this one is about the simply PN junction diode. Now we will meet in next video. Okay, thank you. Hello, welcome to Dr. Subhash Technical Campus, Junagadh. Now today's tutorial topic is about silicon control rectifier. It's simply called SCR. Now let's take a look. Now the symbol of SCR is like this. Here in this symbol there is a anode, cathode and gate. So we can say that SCR is a 3-terminal device. Now in structure, in between anode and cathode there is a 4-layer PN, 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 PN and 3 junction J1, J2 and J3. Here one mistake, here one terminal is gate. So the gate terminal is connected to this P region and is nearest to cathode. So we can say that here this is the gate. So whenever you want to draw the symbol and structure, then you can draw this type of symbol and structure. So this one is about the symbol of SCR. Now why SCR is used? SCR are mainly used in electronic device that require control of high voltage and high power. Means whenever we want to control the high voltage or high power, means at that means high voltage or high current, at that time the SCR is more suitable. This makes them applicable in medium and high power AC supply or high power AC operation, such as motor control function. Now if you want to control the speed of motor, then high power application SCR is used, and SCR conduct when gate pulse is applied. Whenever in gate terminal, whenever we apply some pulses, then SCR become on. Without gate pulse, SCR does not conduct. Means it conduct, but it conduct very high voltage whenever we not give any gate pulse. Now gate pulse is related to the conduction of the SCR. Now this is the 2 transistor analogy of the SCR. Now basic structure is like this. In previous slide we have seen anode, cathode and gate. Here P and PN structure is there, and whenever we connect 2 transistor back to back, means this type of connection, PNP and NPN. PNP transistor and NPN transistor both are connected like this, and it become one SCR. So gate terminal is common between this P region and N type connection, and this is the P and this N, both are separate, and it become one SCR. So it is called 2 transistor analogy of the SCR. Here the symbolic structure to 2 transistor circuit is like this. This is the PNP transistor because arrow is inside. This is the NPN transistor because arrow is outside. So we can say that this is the 2 transistor analogy of the SCR. Now you have to remember most important things of SCR is VI characteristic. This is the VI characteristic. In VI characteristic, the 3 different region you have to remember. First one is reverse blocking region. Second one is forward blocking region, means year to year. This region is known as forward blocking region, and this is the forward conducting region. Now in this characteristic, here the VBO, breakover voltage, here without any gate pulse, whenever we not give any gate pulse and SCR become on, means maximum VBO voltage is required without any gate pulse. So it is called breakover voltage, forward breakover voltage, and VBR is reverse breakover voltage, means without, whenever we give reverse bias voltage and the junction become permanently breakdown, it is this type of region here occurs and it known as reverse breakdown. Now whenever we give some gate pulse, here the IZ 0 means they are not giving any gate pulse. Whenever we give some gate current, in terms of microampere gate current is required to gate terminal. Whenever we give the high value of gate pulse, then SCR become on earlier. Here the two definition you have to remember. First one is holding current and second one is latching current. Here holding current is related to turn off the SCR and latching current is related to the turn on the SCR, means minimum current is required to turn on the SCR is known as latching current, and minimum current to maintain the SCR become on is known as holding current, means below holding current SCR become off, and after the latching current SCR become on. After this region is known as forward conduction state. So you have to take a screenshot and you have to remember this characteristic of the SCR. Now previously we talked about these three operation: the forward blocking region, reverse blocking region, and forward conducting region. These two are connected. Forward conducting region, so you have to remember this parameter for the three. In previous slide we talk about these three condition: forward blocking, reverse blocking, and forward conducting region. So take a screenshot and put down your notebook. So these three operation you have to remember for the SCR VA characteristic. Then application: the silicon control rectifier is used in AC voltage stabilizer, means it stabilize the AC voltage, power or AC current. At that time SCR is used for voltage smoother or stabilizer. Then SCR used as a switch, is a electronic solid state switch, so we can use as a switch. Then another is chopper, means DC to DC converter. If you want to convert fixed DC to variable DC, then chopper is required, and for that SCR is used. Now it is also used in rectifier or is in inverter. Now rectifier is nothing but it used to convert AC supply to DC supply, and the inverter is reverse, means inverter will convert DC to AC supply, then for that SCR is required. The silicon control rectifier also used in power control. Now if you want to control the power, then SCR is required, and the last application is it is used in DC circuit breaker. Now circuit breaker is nothing but one type of on-off switch or protection device, or protection for the AC voltage protection or DC voltage protection. Now one switch is there and it is made up of the SCR. So SCR is used for the circuit breaker, DC circuit breaker, and this all are the application of the SCR, and without SCR power electronic is not possible. If you have any question, then please write to remember chetanb@drsubhashtech.edu.in, and we will see next topic in the next tutorial. Okay, thank you.